Good afternoon, Rich Nass, Executive Vice President with Embedded Computing Design. And I'm here at the SiLabs facility in Austin, Texas. I'm here with newly appointed Chief Strategy Officer, Daniel Cooley. First, let me say congratulations.
Thank you very much. Thanks for having me today.
My pleasure. So in this new role, you have to guide the company to decide which technologies to follow, which ones aren't going to be around. And these are my words, not yours, obviously. But what are the technologies that we should really be concerned about, say, for the next 18 months?
Oh, especially in the next 18 months. And yeah, that's a pretty fair assessment. It's like what technologies and really what's out there for Silicon Labs in the emerging spaces. For the design communities, I think that the biggest trends going on right now are going to be around ultra-low power computing and connectivity. That's kind of IoT. Machine learning and its implementations outside of the data center. Those are coming really, really fast. And security. I think embedded security especially is going to go really, really big over the next year.
Okay, let me pull you back to one of those because it's such a hot button for us. Machine learning. We spend most of our time machine learning at the node, at the edge. I use those terms interchangeably. Some people don't, and I assume that's where you guys will live. Is that true first? And if it is, what do you see? What do you see coming on the horizon?
First of all, yeah, that's true. From Silicon Labs' perspective, we focus mostly on the edge, the far edge, in these embedded spaces. And the machine learning has kind of been living in the data center for most of its existence up until now, where a lot of the training happens, I'll say. Implementing it outside of a data center without the massive compute capabilities has been a technological holdup, not necessarily a market. There's big market push to get as far out as the data center as you can. But we need a lot of new computing architectures to come out, kind of hybrid computing architectures with, parallel computing and CPU together, or even some of the newer technologies coming out where you can do computation and data storage, coexistent inside of a bit cell. And these things are starting to come out. I think you're starting to see a lot of IP providers making these capabilities, and then companies building chips with them so that they can get machine learning to the edge. For implementation, not training. And there's 100 applications that this is going to affect.
Will we see specific hardware from Silicon Labs for machine learning, or is it a software issue and you just use our existing parts?
I can't comment too much on our forward-looking roadmaps. I could say that,
Well, let me re-ask the question. Do we need different hardware than is available today to do machine learning?
Yes. The best implementations are yet to come. So how do you do machine learning on an audio stream or a video stream at the edge on a battery? Okay, forget gigahertz of processing. How do you do it with hundreds of megahertz on a CPU and megabytes of memory and AA batteries? How do you do it out there where you're trying to look for certain kinds of characteristics within these signals that have been trained maybe in a data center but then implemented on the edge node? And you need new hardware for that.
Okay. Now, I think of machine learning as more of a software issue because the hardware that we have is pretty good. Does Silicon Labs have to be the software provider for machine learning, or is that somebody you would partner with?
Well, we have been investing pretty deeply in embedded software for a while. Say that most of the end applications, though, really require a lot of specialized expertise. And a lot of foundational IP has been developed over the last 20 years. For example, in recognizing speech, you can see that really being pushed out in the Amazons of the world, the Googles of the world right now. A lot of that IP is specialized and owned by other companies, so that wouldn't be us implementing it. But our customers are really looking, and in general, customers are looking for the right knobs to turn to implement their own kind of specialized compute algorithms.
Very good. It sounds like you have a fun job ahead of you.
We have a great job, yeah. Great time looking forward.
Thank you very much.
Thank you.